Have you ever stood by a river and really thought about its story? Where did it begin? Where is it going? Well, today we're going to follow one on its epic journey, all the way from a tiny trickle in the mountains right down to where it meets the vast open sea. It's an incredible story of power, change, and how our world is literally carved into shape.
And that brings us to the big central question, doesn't it? How on earth does something that starts so small, a stream you could step over, how does it get the power to carve through solid rock and create something as massive as a canyon? That's the puzzle we're going to piece together.
Okay, so to get our bearings, we need a map. And for a river, the best map is something called its long profile. Just imagine you could graph the river's altitude from its starting point, its source, all the way to its end, the mouth. You'd get this classic curve, super steep at the beginning, and then it gradually flattens out. This curve, this is our roadmap for the entire journey. So here's how we're going to break this down. First, we'll get the big picture of a river's life story. Then we'll dive into that steep, fast start up in the mountains. We'll follow it as it widens out in the middle and then cruise along its slow final stretch. And to wrap it all up, we'll look at the actual tools a river uses to do all this amazing sculpting work.
For all its complexity, everything a river does to the landscape really comes down to just three main jobs. These three processes, they define its entire existence, from the mountains all the way to the sea.
So what are they? First, it erodes, that's the wearing away part. Then it transports, it's got to move all that debris it just broke off. And finally, when it starts to lose steam, it deposits that material, dropping it and building up new land. Erode, transport, deposit, that's the rhythm of the river. All right, let's teleport high up into the mountains, right to the river's source. This is what's known as the upper course. This is where the river is young, it's wild, and it's absolutely bursting with energy. Up here, everything is pretty extreme. The slope, or the gradient, is incredibly steep, which means the water is moving fast. But the river itself, it's actually pretty small, just a narrow, shallow channel. And the stuff it's carrying? Well, we're talking about huge, jagged, angular rocks that have literally just tumbled off the mountainsides. And this is the key to how those amazing mountain valleys are formed. In its youth, all of the river's energy is focused on one direction, down. We call this vertical erosion. It acts just like a saw, cutting relentlessly downward into the bedrock, carving out that classic steep V shape. Okay, now we're following the water as it comes down from the mountains. It's entering what we call the middle course, and it's starting to mature. Its whole personality is about to change. So the slope is much gentler now. But because a bunch of other streams have joined in, there's way more water, which means the channel is getting much wider and deeper. And check out the sediment. Those giant, sharp rocks from the mountains, they've been smashed around and broken down into smaller, much smoother pebbles. And here is where the river changes its game plan. It's not just cutting down anymore. It's gathered enough power to start pushing outwards, carving sideways into its banks. This is called lateral erosion, and it's the force that takes those tight, V-shaped valleys and opens them up into wide, sweeping floodplains. And that brings us to the final stage, the river's old age. This is the lower course. We're on a wide, flat plain now, probably getting close to the coast. The river is just about at the end of its long, long journey. The gradient here is almost completely flat. The river is enormous, super wide and deep, but it's moving so slowly, almost lazily. And its cargo? All that's left are the tiniest, lightest particles, fine sand, silt, and clay. This is the stuff that makes the water look so murky. So, because the river is moving so slowly, it has hardly any energy left. It just can't carry its load anymore. And what do you do when you can't carry a heavy bag? You put it down. The river's main job now switches from carving the land to building it. This is deposition. It starts dropping all that fine sediment it's been carrying for hundreds of miles. So, we've seen the where, the upper, middle, and lower courses. But what about the how? How does a river actually break down solid rock? Well, it turns out it has a pretty amazing toolkit for both erosion and transportation. So, what's in this toolkit? When it comes to wearing down the land, a river doesn't just use one method. It uses 4, and often it's using them all at the same time. Let's break down these sculpting tools one by one. First up is hydraulic action. This is just the raw, brute force of the water itself.
Imagine water smashing against the riverbank. It forces air into tiny cracks in the rock, and that compressed air acts like a tiny explosion, blasting the rock apart from the inside.
Next, you've got abrasion. Now, this is clever. This is when the river uses the material it's already carrying as a weapon. The rocks and pebbles get scraped along the bottom and sides of the channel, acting just like a giant piece of sandpaper, grinding away the landscape. Then we have attrition. Now, this one's a little different. This process isn't about the river eroding the valley. It's about the rocks eroding each other. As they're all carried along, they're constantly crashing and bashing into one another, chipping off their sharp edges and becoming smaller, smoother, and rounder the further they travel. And finally, we have solution. This is the chemical tool. Rainwater is naturally a tiny bit acidic, and that weak acid is actually strong enough to dissolve certain types of rock. Think limestone or chalk. The rock just melts away into the water and is carried off completely unseen. And once all that rock is broken down, the river acts like a massive conveyor belt. It's really cool how it works. The biggest, heaviest boulders are just rolled along the bottom. That's called traction. Smaller pebbles and stones get bounced along in a process called saltation. The really fine stuff, like sand and clay, is just carried along within the water. That's suspension. And it's what gives rivers their color. And of course, the dissolved minerals are carried invisibly in solution. So let's just step back and look at the whole picture. It's an incredible transformation, right? The river goes from this fast, high-energy system that's all about cutting downwards and carrying huge, sharp rocks to a slow, low-energy system that's focused on depositing tiny, rounded particles. It's a complete change of character from its source to the sea. And this quote right here, it just sums up that final act perfectly. It all comes down to energy. When the energy is gone, the journey for all that sediment is over. The river simply drops whatever it can no longer carry, and in doing so, it builds new land, creating those rich, fertile deltas and floodplains that have supported human life for thousands of years. So, we've seen that rivers are the natural architects of our world, shaping the very ground beneath our feet. But that brings up a really important final question. As we build dams, as we straighten out their channels, as we manage their floodplains, how are we taking over that role of architect and fundamentally redesigning the rivers themselves? Something to think about.